Chapter 11. Test Equipment. There are 65 questions in this chapter. Number 1. What is a signal generator? A high-stability oscillator which can produce a wide range of frequencies and amplitudes. Number 2. A dip meter should be loosely coupled to the circuit under test. Number 3. A dip meter may not be used to measure the value of capacitance or inductance. Number 4. What is a dip meter? A variable frequency oscillator with metered feedback current. Number 5. What two ways could a dip meter be used in an amateur station? To measure resonant frequencies of antenna traps and to measure a tuned circuit resonant frequency. Number 6. What does a dip meter do? It gives an induction of resonant frequency in a circuit. Number 7. Which of the following is not a factor affecting the frequency accuracy of a dip meter? Transmitter power output. Number 8. A dip meter supplies the radio frequency energy which enables you to check the resonant frequency of a circuit. Number 9. The dial collaboration on the output attenuator of a signal generator accurately only when the attenuator is properly terminated. Number 10. The dip meter is most directly applicable to parallel tuned circuits. Number 11. If a frequency counter with a time-based accuracy of plus or minus 0.1 ppm reads 146,520,000, frequency being measured could differ from that reading. ppm equals parts per million. 14.652 Hertz. Number 12. What does a frequency counter do? It makes frequency measurements. Number 13. How can the accuracy of a frequency counter be improved? By increasing the accuracy of the time-based. Number 14. The frequency accuracy of a frequency counter is determined by the characteristics of the internal time-based generator. Number 15. If a frequency counter with a time-based accuracy of 10 parts per million reads 146,520,000 Hertz, what is the most actual frequency being measured could differ from that reading? Again, ppm equals parts per million. 1,465.2 Hertz. Number 16. The clock in a frequency counter normally uses a crystal oscillator. Number 17. What factors limit the accuracy, frequency, response, and stability of a frequency counter? Time-based accuracy, speed of the logic, and time-based stability. Number 18. AC voltmeter scales are usually calibrated to read RMS voltage. Number 19. An AC voltmeter is calibrated to read the effective value. Number 20. What is the easiest amplitude dimension to measure by viewing a pure sine wave on an oscilloscope? Peak to peak voltage. Number 21. What is the output PEP from a transmitter if an oscilloscope measures 500 volts peak to peak across a 500 ohm dummy load connected to the transmitter output? 625 watts. Number 22. To compute one of the following, multiply the peak envelope voltage by 0.707 to obtain the RMS value. Square the result and divide the load resistance. Which is the correct answer? PEP. Number 23. How is the output peak envelope power of a transmitter calculated if an oscilloscope is used to measure the peak envelope voltage across a dummy resistive load? PEP equals peak envelope power, PEV equals peak envelope voltage, VP equals peak voltage, and RL equals load resistance. PEP equals square bracket, soft bracket, 0.707 PEV, soft bracket, 0.707 PEV, soft bracket, square bracket, divided by RL. Number 24. What is the output PEP of an unmodulated carrier transmitter of a wattmeter connected to the transmitter output indicates an average reading of 1060 watts? 1060 watts. Number 25. Peak envelope power, or PEP, for SSB transmission is peak envelope voltage, PEV, multiplied by 0.707 squared and divided by the load resistance. Number 26. The power supplied to the antenna transmission lines by a transmitter during an RF cycle at the highest crest of the modulation envelope is known as peak envelope power. Number 27. What is the output PEP from a transmitter if an oscilloscope measures 200 volts peak to peak across a 500 ohm dummy load connected to the transmitter output? 100 watts. Number 28. Oscilloscope measures 500 volts peak to peak across a 500 ohm dummy load connected to the transmitter output during unmodulated carrier conditions. What would an average reading power meter indicate under the same transmitter conditions? 625 watts. Number 29. What is the output PEP from a transmitter if an oscilloscope measures 400 volts peak to peak across a 500 ohm dummy load connected to the transmitter output? 400 watts. Number 30. The formula to be used to calculate the power output of a transmitter into a resistor load using a voltmeter is P equals E, the average of 2 divided by R. Number 31. What is the output PEP from a transmitter if an oscilloscope measures 800 volts peak to peak across a 500 ohm dummy load connected to the transmitter output? 1600 watts. Number 32. What factors limit the accuracy, frequency response, and the stability of an oscilloscope? Accuracy of the time base and the linearity bandwidth of the deflection amplifiers. Number 33. What is the best instrument to use to check the signal quality of a CW or single sideband phone transmitter? Oscilloscope. Number 34. A 100 kHz signal is applied to the horizontal channel of an oscilloscope. A signal of an unknown frequency is applied to the vertical channel. The resultant wave form has 5 loops displayed vertically and 2 loops horizontally. The unknown frequency is 40 kHz. Number 35. When using Lissajous figures to determine phase differences in an indication of 0 or 180 degrees is represented on the screen of an oscilloscope by a diagonal straight line. Number 36. You can use an oscilloscope to display the input and output of a circuit at the same time by utilizing a dual trace oscilloscope. Number 37. The bandwidth of an oscilloscope is the highest frequency signal the scope can display. Number 38. If a 100 Hz signal is fed to the horizontal feed of an oscilloscope and a 150 Hz signal is fed to the vertical input, what type of pattern should be displayed on the screen? A looping pattern with 3 horizontal loops and 2 vertical loops. Number 39. How can the frequency response of an oscilloscope be improved? By increasing the horizontal sweep rate and the vertical amplifier frequency response. Number 40. What signal source is connected to the vertical input of an oscilloscope when checking the quality of a transmitted signal? The RF output of the transmitter through a sampling device. Number 41. An oscilloscope cannot be used to determine FM carrier deviation. Number 42. The sensitivity of an ammeter is expression of the amount of current causing full-scale deflection. Number 43. Where should an RF wattmeter be connected for the most accurate readings of transmitter output power? At the transmitter output connector. Number 44. The range of a DC ammeter can be easily extended by connecting an external resistance in parallel with the internal resistance. Number 45. At what line impedance do most RF wattmeters usually operate? 50 ohms. Number 46. Voltmeter sensitivity is usually expressed in ohms per volt. This means that a voltmeter with a sensitivity of 20 kiloohms per volt would be a 50 microamp meter. Number 47. What happens inside a multimeter when you switch it from a lower to a higher voltage range? Resistance is added in series with the meter. Number 48. A meter has a full-scale deflection of 40 microamps and an internal resistance of 96 ohms. If you want it to read 0 to 1 milliamp, the value of the shunt to be used is 4 ohms. Number 49. A moving coil milliamp meter having a full-scale deflection of 1 milliamp and an internal resistance of 0.5 ohms is to be converted to a voltmeter of 20 volts full-scale deflection. It would be necessary to insert a series resistance of 19,999.5 ohms. Number 50. How can the range of an ammeter be increased? By adding resistance in parallel with the meter. Number 51. The sensitivity of a voltmeter whose resistance is 150,000 ohms on the 150 volt range is 1,000 ohms per volt. Number 52. A voltmeter having a range of 150 volts and an internal resistance of 150,000 ohms is to be extended to read 750 volts. The required multiplier resistor would have a value of